Hello students. So today we are going to start a new chapter, and the chapter is all about relationships. So I have sent you already a revision regarding your PDM and IMD, what I call them, the unitary methods. So in the unitary methods you have seen that there are two kind of relationships. One is the direct one is the indirect one. Now, uh, to get the reference, I'm just telling that let's say we have five pens cost like let's say 15 rupees. So it is obvious that if I increase the number of pens, so if I have let's say six pens, so obviously this number will increase, right? So I will be needed this much of money. So you can see one thing clearly that where my number of pen is increasing, my rupees is also increasing. So if we have two quantities like this, one is pen and one is rupees, and the both of them increase in a similar fashion, that means the increase of this quantity is dependent on the increase of this quantity. So when they are correlated with each other, okay, they are in a direct relationship. Direct relationship. Okay. Now, if we make a chart of this thing, you can see that let's say I'm just having a chart. So here I'm writing the number of pens, and here I'm writing the money I need. So 5 pens 15, 6 pens 18, 7 pens 21, 8 pens 24, and 9 pens 27, and so on. So you can see here one thing that like just like pen is increasing, the money is increasing also. If you take the ratio of pen by and pen to money, let's say I am denoting the number of pens in x. So x is the number of pens and y is the price of those many pens. So if I do, you can see if I take the ratio, so if I take 5 by 15, I will get, or if I do the money versus pen, that will be good enough. So let's say I'm doing y by x. So you can see that either this is 15 by 5, I'm getting 3, or this is 18 by 6, I'm getting 3, or it is 21 by 7, even I'm getting 3. So you can see that the ratio of money to the pens, number of pens, is always same, and that is 3. So I can tell that here this ratio between two quantities, one is money which is represented by y, so money I have represented with y, and pen that I have represented with x. So this ratio is always equal to 3 in all of these cases. So you can see that in this case I can also write from here using algebra that y is equal to 3x. So this x is going right hand side and it is becoming a multiplicative factor. So whenever you see something like this, that means this equation means, so this is the equation, this equation means that if I increase the number of if I increase the x, y will increase automatically. So you can see that y is dependent on the value of x here. So you put x equal to 1, y will become 3. You put x equal to 2, y will become 6. You will put x equal to 3, y will become 9. So y is dependent on x, and in this case, if you have two quantities like this with a multiplicative constant like 3, 5, whatever constant, any integer value or any fractional value, but it has to be a constant that is multiplied with another parameter like another quantity. Okay, so in that case you can say that y is proportional to x. This relation is called direct proportionality. So this is proportional relationship, you can say proportional. So this is direct proportionality. Because I'm writing here direct, that will be better. So this is direct proportionality. Okay, so it is not fitting here. So this is called direct proportionality. This sign here you better use like this. So this is this and this. You can use like this. There is a gap. There is a small gap between this 2 point. So this sign means that one of my quantity is dependent on another quantity, but the relation here is direct. That means if my value of x will increase, the value of y will increase as well. Okay. So what kind of questions or the numericals we may have? So let's say these things can come. Let's say there is a like tag of rice and there is a price. So this is the amount of rice, the first one, and this is the price. So let's say we are telling that 3 kg of rice is let's say this much rupees. Okay, then we are telling that let's say okay, let me think. Acha, so okay, let's say this is 350 and this is not given. Again, let's say this is 7 and this is not given. So this kind of question can come. So what you have to do, you have to see that these two quantities are in which kind of relationship. So you can basically use your common sense that yes, if I need more rice, I need more money, right? So the relationship between rice and the price, so the amount of rice and the price is always direct. Okay, so this is always a direct relationship. So if the amount of rice is increasing, it is very obvious that the price will increase as well. Now, if you see this is 3 and this is 210, so we have seen that in case of direct relationship, or you can say in direct proportionalities, this one quantity and the second quantity, if we take the ratio, we get a, in case of direct proportionality, if we have the ratio, we get a constant value. So if you remember that in unitary method, there are two methods I have told. One is PDM, one is IMD, right? We are talking with this PDM. What this PDM means? Actually, this PDM is totally my imagination. This is not there in the book, but this is good for your, like what you say, so that your shortcuts. Okay, so that you can do the maths easily. We are not bothered about this IMD right now. We will come to that. So in PDM, P stands for proportionality, which we are doing now. So this is proportionality or proportional relationships when two quantities will increase together. In case of proportionality or proportional relationships, here we have division at first. So you can remember like that, when we have a PDM case or a direct proportionality, division is the starting point of my math. So this you can remember, and we can find here that The ratio, division matlab the ratio. So if we take price versus rice amount, so we get from the first value we can get this. So this is 70. So price by rice ratio is 70. So now you see one thing, price by rice ratio is 70. That means I am rubbing this. So that means this ratio has to be same for this also, this also. So in order to make them same, so I can write that price by rice is, so this is 350 by something that also has to come 70. So what this value has to be? Now I know this has to be 5, right? So this has to be 5. So that means this answer is my 5. Again I do for the next one. Now price by rice has to be 70. Now my downside is 7 and this is not given. So how much this has to be? So this has to be 490. You can use your algebra to find it out. You can directly multiply this 7 that side and that will be like very easily that can come out. Or if you say that, then I can do it for you once I will show you. So let's say that this last one we are finding. So you can put that x, which I don't know, the price I don't know, by 7, which I know, is 70. So from this equation you can easily find out that, so this, from this we can write x is equal to 7 into 70, which is this. So instead of question mark I can write the answer. So this kind of question can come. So you have to first, what is your first priority or first step to do? You have to see these two quantities, okay? Ki how these quantities are, like what is the relation between them? Are they direct in nature or they are not direct in nature? Now come to the inverse one. Some places you will have this kind of value, ki your man, which is very like easy explanation, man and days. So the number of man and days. So you can see that in some cases, let's say 5 men are there working to build a home. They need 10 days. Now 10 men are there working. They need 5 days. Now let's say something more like let me think. Okay, 2 men are there or 25 men are there. I need 2 days. So this is something, this kind of situation may also come. So in this case you can see that this man and days are not in a direct relationship, where my number of men are increasing, my number of days decreasing. So one quantity is increasing here, whereas another quantity is decreasing. This kind of situation is called inverse relationship. I have shown you in the unitary method also that inverse relationship I have used this IMD. I stands for inverse. This is just to remember, okay? And here comes the multiplication. Multiplication. Now, if I remember this, you can see here clearly that this man into days, if I do for all of them will come 50. 5 tens are 50, 10 fives are 50, 25 twos are 50. So the multiplication is a constant, okay, in this case. So in the last case you have seen that your ratio is a constant. Ratio is constant. So in this case you will see multiplication is a constant. This relationship is called inverse relationship. So from this I can write in this I can write that the man, okay, I'm writing this again, the man into the days is 50, right? So I can write that man is equal to 50 divided by days. When we have this kind of situation where we have a constant upside and the quantity is downside or in the denominator, that means man is is in the relationship like this, 1 by days. This is called inverse relationship. Okay. So in this chapter there are two kind of relationship. One is direct, where the ratio is a constant, and one is the proportional inverse, where the multiplication is a constant. So what kind of math can come? Similarly, like what I told you, that let's say men and days. So let's say the man is like 10 men are working, and they have worked for, they need 6 days. Now let's say 12 men are working, they need 5 days. So now if I remove this, okay, and if I remove this also, like let's say this is removed, and this is there. So how to do this? So you can see from the first one, I say that this relation is an inverse relationship. So the multiplication is always constant. So let me find out men into days is 10, 6 or 60. So that means in all of these cases this has to be same. Now I have to find for this one. So let me take this as x. So I can write that 12 into x has to be 60. So x has to be 60 divided by 12, which is 5. Okay. So instead of x I can write here 5. So something like this we have to do. And the code for the next class is you are a very good student. So this code you have to tell me to enter the next class, so that I can understand that you have seen the full video. Okay. So continuing. So this we have to do for the next case also. So let's say this is now x. How x? I can write here again. X into 4 has to be 60. So x will be 60 by 4, that is 15. So instead of x I can write here 15. So this kind of math can come. So this much was there for today. I will send you some of the maths from the book itself. Please try to do. And unitary method is like very much close to this. Okay, like in unitary method you have only worked with two situations. Like one is given, the 6 pen cost this much, how much this many pens will cost. But here you have to find for all. You have to find for, let's say, 5 also, 4 also. Some more data can be given even. So in this situation this is much more convenient for you to do. Okay, so this much is for there for today, and we will have the live class next day. Okay, bye bye, see you in the next class.